So, today we'll start discussing on booting of operating system. Now, for this, first of all, we need to think of a scenario. Think something like we have a computer to which multiple hard disks are connected, and every single hard disk having multiple partitions on it. So, for simplicity, assume there are two hard disks and each hard disk is having say 4 partitions. Now my computer also has got DVD writer in which I have inserted say bootable DVD or CD. Okay. Third thing, suppose I have bootable pen drive which is also attached to my computer. So two hard disks, one bootable DVD, one bootable USB. Okay, and we just power on the computer. Now suppose in DVD we have Ubuntu operating system, on pen drive we have say Debian operating system, and on two different hard disks we have say Windows and any Linux flavor. So at 4 different places we have 4 operating systems. Maybe out of these 4, 2 have installed and 2 have not installed. And when you power on such a computer, how exactly booting process starts? Which one is booted? And what is sequence of that? So that we want to discuss in today's lecture. Everybody got the scenario I just mentioned? Fine. Now, very first thing when you power on your computer is something called as BIOS, which is basic input output system. Okay, so basic input output system. So when your computer is turned on, the very first thing happens, that is BIOS, basic input output system, which is actually available on say EEPROM. Okay, we also call it as a CMOS setup. Small battery is there and small EEPROM is available. On that EEPROM, this basic input output system is available, whose task is to initialize the hardware. Okay, so after that what happens is the most important thing called as POST. POST stands for power on self test, which will quickly test whatever the basic minimum required hardware is there. One of the funniest message given by post is something like keyboard error, press F1 to continue. Okay, maybe like for example, if RAM is not there, then your PC won't start because that will be handled by BIOS. But say for example keyboard is not attached to your computer, so definitely it says the keyboard error or there is no keyboard, something like that. But still again important thing is it says press F1 to continue, right? If keyboard is not there, I don't know how to press F1 key. That was the funniest message, right? So the post after bias, what comes is the post which will try to test quickly for possible errors. Okay. After bias part, it is typically called as bias boot handoff, where it will select one of the disk. Now how it selects, say for example, as I mentioned, if there are two hard disks, one CD-ROM or DVD, one USB. Now in this case there is something called as boot device priority. Even network boot is also possible if you are connected to the LAN and we have a bootstrapper there in LAN. So there is something called as a boot device priority. So for example, maybe we have a CD-ROM, then hard disk, and then USB, something like that. Now in that case, definitely priority will be given to CD-ROM. Okay. Now if it is hard disk, fine. Now two scenarios here again. On single hard disk, two operating systems are there, or we have a two separate hard disks. Okay. Now in case of two separate hard disks, fine, whichever disk appears first in boot device priority, that will be selected. Got it? So that is boot device priority. But what if a single hard disk having multiple partitions and on which multiple operating systems are there? Now which operating system will be loaded? Okay, so that part is not available with your BIOS. So from BIOS, the boot handoff will be just to the MBR, where meaning of this MBR is master boot record. So this handoff will be carried out by like BIOS calling the code stored in the MBR at the start of disk 0. Now disk 0, even though it is written here, meaning of that is whichever disk comes first in the boot device priority. Okay, so now there comes into picture called as MBR, master boot record. Now anyways, we'll see the details of MBR also. So let us move to the master boot record. Now the master boot record, around, it's a very small record actually, around 512 bytes are there, and this is like at the beginning we have something called as a bootstrap code on the master boot record. Then there is kind of index of partition table. So whatever the partitions we have created, now which partition starts where at a hardware level, it will be in terms of cylinders and tracks. Okay, so on which cylinder number, on what track number, which partition starts, so that kind of entry index kind of thing is available there. That is the partition table, and then something called as a boot signature will be available. So this is very small thing actually, master boot record. Okay, so on where this is located, remember master boot record will be available for each and every hard disk. So for example, as I mentioned, if two hard disks are there, two master boot records will be there for every hard disk, right? Then which will be loaded? That will be decided by the boot device priority. Fine. So once boot device priority identifies hard disk, then processor will look for the MBR, which is available with every hard disk, except for something like we have small floppy disk. Earlier days we used to have floppy disk in which uh, master boot records are not there, and they do not allow actually creation of partitions. Okay, so it is a single partition where first 512 bytes may be utilized for bootstrap code directly. A tiny operating system like MS-DOS, which can be installed on the floppy, it automatically starts with that. Okay. Now next thing is the bootstrap code, and this bootstrap code is around 440 bytes out of 512 bytes. That will be, actually it could be anything that will be loaded and that will be used to execute it. Okay, and final 2 bytes, they are called as the signature, boot signature, and that is just used to determine if the selected boot drive is actually bootable or not. So small signature kind of flag is there, where it will denote like this disk is bootable or bootable partition is available in this, something like that. Now next is the partition on the disk. Now out of, like for example, I mentioned 4 partitions here. Now which partition is selected for booting? So again here there is concept of the primary partition, and second one is the logic extended partition, in which we usually create the logical drives. Okay, so primary partitions are used for booting purpose. Now can we have multiple primary partitions? Yes, we can have. Now then question is which partition, right? So even though we have multiple primary partition, at any given instance of time, the partition which is active, that will be used for booting process. And note that even though we have multiple primary partition, at a time only one will be the active partition. Okay, and once that partition is selected, now that has something called as a file system header. So whenever we have partition, we need to format it first of all. I guess everybody aware of it. Even we format the pen drive. And formatting is nothing but employing some sort of file system on that. Okay. So on that we have file system header, and there is something called as a jump, very first part, which is pointer to the bootstrap code, and this actually points to the bootloader. So this is the partition on disk. So we have jump, right? Then file system header, and then bootstrap code, and this bootstrap code is used to point the bootloader. Now this bootloader, now if there is a single operating system, say for example Windows is there, then Windows loader will be there. If it is Linux, then could be something like Lilo or Grub. Even Grub is having capability of create entries for multiple operating systems. Even that is true with Windows. Like multiple versions of Windows can be also installed. That thing is possible. Okay. Let me check. Somebody has posted something. What is this? If a machine has boot device priority set as USB hard disk, CD-ROM, and I enter a bootable USB, the OS on my pen drive will boot. Yes, correct. Now, whatever you mention is perfect. That is, see, the boot device priority is a sequence. Now, for example, if I have a USB in the list first, now if I attach bootable USB, my operating system will start from USB. If it is absent, it will look for next boot device priority. Next question is, while formatting we see FAT32 and NTFS, which one is preferred? See, the file systems have different capabilities, right? Now, FAT32 is the most common for pen drives, but if you are going with hard disk, I suggest go with NTFS. Now, what is the difference? Now, each file system has their own advantages and disadvantages. How much space they will occupy for file system itself, what is the largest size of file supported by that file system. So based on that, and whatever you mentioned, FAT32 and NTFS, it is just for Windows operating system. But if you go with Linux, there are other file systems are there. Typically extended file systems they are called as, like ext2, ext4, even xfs, Razer file system. So many file systems are there. Okay. Even if you think of what is that, ZFS, that is the file system used by BSDs. Okay. Next is the bootstrap will point to the bootloader. Now, most of the time in our laboratories, you have seen that grub bootloader is there. Grub, GRUB, which actually stands for Grand Unified Bootloader. GRUB. Even Lilo is also there. LILO, where LI stands for Linux and LO stands for loader. So bootloader is any something like operating system loader kind of a thing that will be executed, and now it has the record of where is the kernel of operating system. Okay, because operating system booting starts with its kernel and beginning of that kernel, so that address is available in the configuration of bootloader. As an example, if you think of grub as the OS loader or bootloader, grub will have entries even though you have multiple operating system. So there are entries in that. So for example, Windows will be on disk number 0, partition number 2. Say Linux is there or Ubuntu is there, so disk number 0, partition number 4, something like that. Okay, and once that kernel is reachable, so typically bootloader first upon present you some sort of boot menu. That is what we see when we have dual boot operating system. So wherein first upon maybe for example I installed Ubuntu and Windows. So Ubuntu, maybe two additional options of Ubuntu will be there. One is something called as for say the repair mode, or one more is like for example you have, if you are updated and another kernel is available, so you can go with either of that. And maybe at the end we have something like Windows operating system. Okay. So from boot menu we select the operating system, and now when we select that entry, actually control will transfer to load the kernel of selected operating system. Okay, so that address will be there. Fine. So once kernel is loaded, now next part is important. There is very first thing, that is, let me make use of bullets here so I can type it. Once, what happens after kernel, right? So when kernel is loaded, very first thing, okay, there is question, what is it, what is a kernel? Fine. Kernel is program available in any of the operating system, which is the core component. Rather, in few textbook, kernel itself is called as the operating system. Like for example, we say Linus Torvalds created the Linux operating system. What actually he created is the kernel, in which the important tasks like memory management, scheduling, resource management, all that stuff is, so this is core component of any operating system, that is kernel, which is running always. Okay, so whatever your system calls are there, they are implemented in it. Fine. So once kernel is there, it starts with init. So init is the process, very first process rather I can say. So this process will be created. Even before init, it is said in Unix that there is process 0, where init is like process 1, and that process 0 becomes swapper. Now memory management, when we discuss about memory management, we'll come to know what is use of that swapper process, which is used to swap the processes to and from the virtual memory and the primary memory. That we'll see later. But remember, for right now, init is the thing we need. So this is the very first process that will be created, and now this process has some sort of configuration. In case of Linux operating system, that is available as /etc/init tab. So that is the configuration file. So init, once started, init will load this configuration file, and then there is something called as run level. Okay, so different run levels can be used there. So from run level 0 to run level 6, total 6 run levels are there. Now in case of Windows also maybe similar kind of stuff is there, but because it is closed source, we don't know its details. But Linux, as it is open source, you can go and check the contents of etc init tab, but do not modify it here. Okay, so there is something called as run levels. Let me talk about run level number 5, which is the graphical user interface. Run level 0 means shut down the computer. Run level 6 means restart the computer. Run level 1 is single user. Run level 3 is multi-user but without graphical user interface. Run level 4 is not used. Run level 5 is graphical user interface. So it is a multi-user with GUI, graphical user interface. And for this run level, what are other processes that needs to be created by init, they are mentioned, and they are available in something like rc.5, run level rc.5. So this is a folder in which so many processes are there. They start with either S or K, where S means start the process, K means kill that process. Okay, so that is what the run say in Windows operating system also. We usually say start normally or start with safe mode. So these are like different modes to start. and that is the reason if you go with, let me tell you the command, something called as a ps3. ps3 is the command used to see the hierarchy of processes in your operating system, ps3. So if you fire this command, at the top you will come to know init is there, and that is the reason init is called as grandparent of all the processes. Fine. And maybe at last this init process starts with login or something called as bash, which is the shell. So after login you will get the bash, or if it is graphical user interface, then login screen will be presented to the user. Fine. Any doubt in this? Any doubt in this? So what I mentioned is we started like multiple hard disks, multiple partitions, USB and DVD, everything is connected, and all four have some sort of booting or bootstrap code. Then it starts with where to fire the ps3 command. It's in a terminal. Just open the terminal, any terminal, and fire the command ps3. Okay. So that will show you at the top init is there. Even you can see the contents of etc init tab. Not necessarily init tab, there is something called as the fs tab also, where instructions are there to load your file system. Anyways, file system we need to see later on, but at least here when we start power on the computer, it first upon goes to the BIOS, which is available on your motherboard, and contents are preserved with some small battery is also there, and that is the reason even though you shut down the PC say for 15 days, you will get the correct date and time still, because that is stored somewhere. Okay, so that clock is running because of that small battery. Now next important thing is, from BIOS very first thing is power on self test. So let me mention that sequence here: power on, then there is a BIOS, then there is post power on self test, then it looks for the configuration in the BIOS, where importantly it looks for boot device priority. Once you select the device from the priority, what is available there is master boot record. From master boot record, it will look for active, this part is important, active primary partition. It will look for active primary partition. Okay, where it will find the bootstrap code, and from this it will move to bootloader, and once bootloader is available, it will present menu to select the operating system if multiple operating systems are there, and from that first upon it will create init, which will look for configuration init tab. It will select the run level and required processes will be created. Typically at the end, login process will be there, where you are supposed to do authentication, where you provide username and password, and then operating system is ready to provide you the service. Any doubt in this? Do you have any question? The same flow is mentioned here: BIOS to MBR to active partition, and then it goes to bootloader. Very simple thing. Any question on this? So that is operating system booting. Should we move further? Fine. So let me stop these slides, and the next part which we want to start is the types of operating system. So let me share it. Fine. Is it visible? Okay. So the types of operating system will look. This is also called as the evolution of operating system. So whatever the modern operating system we see today, it is not as it is available since its beginning. So it's the journey of operating system started with serial processing, serial operating systems you may call it, then batch processing, then there is concept called as unitasking and multitasking. Okay, so the time sharing operating systems, then distributed operating system. At a conceptual level, we'll see distributed OS, network OS, and real-time OS. Okay, so that is kind of a sequence for the evolution of operating systems. Let us start with serial processing or serial operating system. Now in this we have very limited hardware, were not sophisticated operating system. There is no sophisticated operating system available. Let me ask the question, have you done programming on the kit? The hexadecimal keyboard is available, and maybe 885 or 886 processor. I guess Anshuman kits were there. Have you done programming on that? No, not on the kit. Okay, fine. Somebody is saying yes, somebody is saying no. I guess the students who are saying yes, maybe uh, they are done in at diploma level, possibly. Shailesh Mohitte says in 12th. Fine. So, anyways, it is a small box in which hexadecimal keyboard is there, and your processor and whatever different the bare minimum chips, something like 8155, 8255, 8253, whatever the uh, chips are there, kind of motherboard you will have there, and very small 7 segment display is there in front of you. Maybe nowadays display is also modified to digital, but 7 segment display is bare minimum thing available there. And then how we write the program is, see, each and every processor provide its instruction set, the instructions that can be executed by that processor. That is the instruction set of that processor. Now for example, if 885 processor is there, now we have the data sheet of that 885, something called as a mnemonic code. Okay, so if instructions are there, something like add, sub, add immediate, load, store, some sort of machine level instructions are there. So we write the code in assembly, and even on that kit there is nothing like compiler or assembler which will convert that code to executable, and it has to be done manually. So usually we look for that data sheet or the mnemonic sheet, will identify the instruction, and in front of that instruction code, which is hexadecimal number for that instruction is available. So we need to write the sequence of code. Okay, and once we do this, then we type that code using that hexadecimal code. So something like start at some memory location, so whatever the address of memory is there, and then we go on adding those instructions there. And once we add instructions there, that means we are again manually doing the task of loader. So we have written the code in assembly language, right? Now there is nobody to convert that code into the machine language. So we did that manually. So we performed the job of compiler, say, or assembler for that matter, and we created executable code, and this executable code is on my paper, right? On a piece of paper we have written that, and now we need to load this program into the kit. That is what the task of loader is there. And once we load it, then we give some sequence to start execution from where we have installed or where we have loaded our machine code. Imagine, so there is no editor to write, there is no compiler, there is no linking and loading, everything is done manually. Still we can execute the program, and at a time, that is kind of serial processing. Okay, so compiler, just if you give the starting, usually the last instruction for such is a halt instruction where execution stops, maybe whatever the results we have displayed there. That is the serial operating system. Early days, they run from some sort of display lights are there, or toggle switches, as I mentioned. Very small input devices are there, and maybe you can attach printer, just kind of line printers or character printers that will be printed, and we need to do everything manually. That is the serial operating system. Okay, now from serial operating system we moved to batch processing or batch operating system. Now this is the important for now small a dedicated program, even though we cannot call that as an operating system, but there is a small thing available, something called as a job monitor, whose task is to sort the jobs. Now why to sort the jobs, we'll see. uh, I just got the message of WebEx that meeting will end in 5 minutes. So fine. So what I'll do is we'll stop here, and from tomorrow we'll continue with batch OS, and we'll make use of these 3-4 minutes for question answer. So if you have any doubts, you go ahead. If you have any question, please type in the chat. 60 participants are there. Not a single question. Let me check if I can connect to internet and see that Anshuman kit. Let me share it. So I'll stop sharing this, and this is the Anshuman kit. This is the, can you see this? Yes. So here you check it. A small wooden box. This is the hex keyboard. This red part is your display, and here you have different chips including your processor also. And we used to write program on sheet of paper, input it here and run, and you will get the output here. Okay. uh, there is a question in chat: how to decide how much of primary memory to allocate for an operating system? No complete operating system should be loaded into the memory. So whatever the core part of this, which is kernel, right? And then operating system decide how much memory to allocate to other processes. It is not us to decide how much memory to allocate to OS. It is exactly reverse. Operating system allocates memory for our applications, and operating system has to be loaded into the memory. Okay, that is the difference. So we don't allocate. Okay.